this lecture, presented by www.free-academy.com, we have another user-submitted question. This question is, we're given the function h of t equals t plus 3 to the third divided by t minus 1 squared, and we're asked to use the second derivative test to find the relative maximum and minimum of the function. Now, if you go and calculate these derivatives by hand, you're going to find that they very quickly turn into a convoluted mess. So, I use the wonders of technology to calculate the first and second derivatives for me. So great, we have these. Now I don't know why it says use second derivative test to find the maximum and minimum, because your maximum and minimums occur where your first derivative is equal to 0. At least generally. I mean, you can have inflection points where it's equal to 0, but otherwise, maximums and minimums occur like this. So we need to find where the first derivative is equal to 0 before we can really find anything. So that starts out by setting the top of the equation equal to 0, because when the top is equal to 0, the whole thing is equal to 0. Now again, that's a little bit of a mess algebraically, so use a calculator, and you get that the first derivative is equal to 0 when t is equal to -3 or equal to +9. Now, you can do this a little bit more efficiently by using the second derivative. Finding the second derivative equal to 0 gives us our inflection points. So, we'll set the top of this equal to 0, and then we'll get that t is equal to -3 as an inflection point. But, I've even gone a step too far, too, because we don't know that's an inflection point until we put in test values. So you would need to set up the table, do your interval from -infinity to -3, and from -3 to +infinity. Well, that doesn't look anything like a +infinity. Let's start by doing the value 0 in, and we're going to get 228 divided by 1. That is hugely positive. Well, that doesn't work. We can do 0 over here to get something that's hugely positive. And if we take a test value, say -5, we can calculate this all out, and we're going to get a negative number. That will be concave down. This will be concave up. So in which case, we do know that -3 is equal to an inflection point at this, so we don't know that that's not going to be a relative maximum or minimum. In which case this leaves us 9. We know that 9 occurs in the interval from -3 to +infinity, and we also know that this is concave down, which means 9 must be a relative minimum. And we can also assume at this point that that is the only relative extrema. And what I'm going to do to prove this, we'll bring up the graph here. And you can see we have an inflection point down here at -3. It's concave down before, then it'll switch to concave up after that. And then here at 9 we have a relative minima, and this will just go on and on. So that answers our question completely. Keep sending us more.